Daddy, where are we? We're at the last stop, bruh. Last minute data analysis, page 505. Dad, do I have to cut the lawn? Yes. No, I'm not going to cut no lawn because I got to do Mr. Alberto's SAT homework, data analysis, last minute. So if we got just a few days before the test, how do we beat down these 2, 4, 5 questions? We're going to beat them down like they need to be beat down with a stick. All right, remember during the test, when you're taking tests, you're going to have access to paper, scratch paper to write down information. That is the magical trick of beating an exam. It's not Desmos or your calculator, it's actually your pencil. So far for data analysis, I don't think there's one time that I had to use Desmos in these 5 pages of questions that we've gone through. But bruh, you've learned a lot. If you follow well, actually, there's 6 videos, right? The big introduction and then the 5-page document, 1 page per or 1 video per page. You have learned so much that if you were to take the test tomorrow, you will beat down data analysis questions like it should be beaten down. This question number 2 is an easy question. Now, remember, we have 5 questions. If you're doing this for homework, it should take you about 2.5 minutes to go through the questions to identify your weaknesses and also identify the ones that you do own, like this question. I know you own this question. But what do you do with the rest of the time that you have left over? You set aside 15 minutes, so 2.5 minutes going through the questions, and then the rest of your time, your 12.5 minutes, then you review the questions that gave you trouble. But if you don't need the entire 15 minutes and you understand everything in 10 minutes, then so be it. Boom, you are done. But then go back to the previous pages that gave you trouble. If you do this on a daily basis, you're going to be a monster for the exam, especially if you have more time to prepare. But let's pretend we only have 5 days, 4, 3, 2, 1 days, 24 hours to get ready for the test. And maybe it's just 10 p.m. at night before the test. What do you got to do? Just follow what I ask you to do, but set your expectations. If it's last minute preparation, don't expect to hit a home run, but you're going to crack the bat pretty well in that ball. All right, ladies and gentlemen. Question number 2. We examine the chart first. What do you notice? A positive slope line. If it is a positive slope line, then what's the rise over run? Can you calculate it? Notice we have dots, right? We have a bunch of measurements and dots. That's what I'm noticing. Whoop, 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 whoop. So these dots existed before that line was drawn. Then somebody said, ooh, I see that we can draw a line through here. I can come up with a slope-intercept formula. And since this is question number 2, more than likely, they're just going to ask us, what is that formula? Let's read carefully. Scatter plot shows a relationship. A line of best fit also shown. Which of the following equations must best represent the line of best fit shown? Well, if it's positive slope, answer choices C and D are done because those are negative slope lines. So it's got to be between A and B. Where's my y-intercept? My y-intercept is a little below 4, and it's a positive, and it's not a negative. So B is out. A has to be my answer. Hoo. Next question. Oh, 20. This is supposed to be a hard question. And it's the same thing. You got a bunch of dots, different measurements, of which there are 7 different measurements, 7 different dots over time. So your x-axis is all about the time in minutes, and your y-axis is all about the temperature. Easy to understand stuff. Now we read, during a study in temperature, the degrees Celsius, the air in the chamber is recorded to the nearest whole number. Integer is a whole number, negative or positive, including 0. The scatter plot shows the recorded temperature in Celsius of the air of the chamber X minutes after the start of the study. Cool. What was the average rate of change? Average rate of change is rise over run. That's code for rise over run in Celsius per minute of the recorded temperature of the air in the chamber. Oh, this is quite. My brain was thinking question 2, but I was like, whoa, this is tougher than a question number 2. Of the air in the chamber from x equals 5 to x equals 7. Oh, let's go there. X equals 5 to x equals 7. You with me so far? I put those big dots there. All right, let's go to the dots where they're located. One is located at 14, and the other is located at 7. I'm sorry, at 24, right? All right, so my rise over run. Let me do my rise in blue. When I go north, because I'm going to make a right turn to go to the other red dot, I'm going north. How far am I going north? Notice the measurements. It is 2, 4, 6, 8, and 10. So my rise is equal to 10 over my run. What is my run going to be? Let me do that in green. It's going to go a direct line to the red dot. Now, what's my distance there? It's a distance of 1 and 2. Increments of 1s, right? Going across on the x, increments of 1, but the y was in increments of 2. So that is all over 2. What does 10 over 2 equal? 5 is your answer to this question. It's just your rise over run. And that's it, ladies and gentlemen. And that's supposed to be a hard question. Is that super hard? Nope, it ain't that hard. But most students are unfamiliar with what to look for and what to do. Now you're much more familiar. So you would own a question of that type. All right, this question number one. We know that this question number one must be easy. Easy. I mean easy. I'm saying easy like my uncle used to. Easy. Easy doggy. All right, here we go. Question number one. Examine the chart. On the x-axis, you got years. On the y-axis, you got percentages. Example, what is the lowest point of percentage at what year do you have the lowest point of percentage? Oh, it looks like here, the lowest point of percentage, it looks like it'd be 2014. What's the highest? What year do you have the highest percentage? It looks like, well, I got here, here, and here. It looks like 2010, 2011, 2012. What would that be in percent? It looks like that's 10, 11 at 12%. So you guys can read this stuff. You guys are good to go. All right, let's read the question. This is super easy. For what model year is the percent of cars for sale the smallest? Oh, I think we did that earlier. What year is it? 2014. Who? All right, that choo-choo is rolling. Oh, let me clear this up a little bit. I don't like getting confused. All right, here we go. Does this need to be desmotized? No, we're not going to desmotize this, but let's take a look at the chart. Now, this would be like an easy to medium level question because it looks like it's not that easy, 1, 2, or 3. But some students may have goofed because they're moving too fast. These are bar graphs. They're easy to read. So what's your x-axis all about? Groups. We have 1, 2, group 1, group 2, group 3. What's your y-axis all about? Number of cans. So if I have group 10, how many cans do they have? They have 20 cans. Group 5, how many do they have? A little less than 50, etc. And done. The bar graph, let's go into the question. The bar graph shows the distribution of 419 cans, okay, collected by 10 different groups. Here, they could ask you what is the average? That'd be 410 cans divided by the groups. What's the average per group? Stuff like that. You're just anticipating, but you're not jumping to conclusions. You want to read the question. Question is asking, how many cans were collected by group 6? What? That's it? Where's group 6? Right there. If I go up my bar, it ends right here. What does it match up with the y-axis? 40. And that's it. That's how many cans. Ain't that easy? Yeah, there are easy chart and graph questions. I introduced you page 1, 2, 3, 4 to show you some of the toughest ones because they're actually going to make your life easier when you see stuff like this. Question number 5. We know that this must be easy, but this is testing margin of error. So there's a little transition here. But if this comes up seldomly, right? But if it does come up, you're going to own this. Check this out. An analyst collected. Wait. First of all, margin of error. You probably don't even know what that means, but it will be explained. So whenever you see the words margin of error within the question, you got this owned. An analyst collected data on the price of a carton of grape tomatoes at 30 locations. All right, cool, 30 locations. The average price, the mean price of a carton of grape tomatoes in Utah was estimated to be 423. So my average is 4.23. We cool? So I got my label, my average. But then we see with an associated margin of error of 0.08, which means your margin of error for that average of 4.23, because the sample size is not perfect, it's an average. It means that it could be plus zero point zero 0.08 or minus zero point zero 0.08 of 423. You guys get it? So what could be the range of these values if we added 0.08? That's going to be 4.31. If I subtracted 0.08, that would give us 4.15. We good? All right. Now, which of the following is a plausible statement about the mean price of a carton of grape tomatoes for all locations that sells this product in Utah? The average came in at 423, but we could be off a little bit by zero point zero 0.08 cents. So it could be between 415 and 431. Which one does that match with? Is it D? It is greater than 431? No. It is less than 415? No. It is either less than 415 or greater than 431? No, it's in between that. And A is your best answer. All right, guys, that pretty much wraps up. These 5 pages wraps up the types of data analysis questions that you will come across. If you need access to this document or if you need access to more information, then you better give me just a shout out by texting me to 786-877-7231. And don't forget to subscribe to this channel because when I come out with other videos, I'm certain that you guys want to be alerticized. And if you're alerticized, then you're going to beat down SAT questions. All right, guys, till the next one, we're going into the next realm of geometry. Later.